Assalamu alaikum, students. Students, today we are starting the topic ionization energy, that is an atomic structure in the first chapter of AS chemistry. So, you know what is ionization energy? Ionization energy is actually the amount of energy needed to remove one electron from each atom of one mole gaseous atom. What is the meaning of this? You have one mole gaseous atom. You have one mole atoms. You have like 6.0 to the power 23 atoms. You are taking out electron from each atom against its nuclear attraction. More the nuclear attraction, more energy is needed to take out the electron. So what is ionization energy? The amount of energy needed to remove one electron from each atom of one mole gaseous atom. That is called first ionization energy. When you are removing the second electron, second ionization. When you are removing the third electron, third ionization. So in aluminium, there are 13 electrons. Removal of first, removal of second, removal of third, removal of fourth, fifth, sixth, seventh, 8, 9, 10, 11, 12, 13. So these are called successive ionization energies. From atom, you take out electron against nuclear attraction. The nuclear attraction depends on number of shells, atomic size, radius, shielding electron. So in the previous lecture, we studied about what? Atomic radius. Now we are going to link atomic radius with the ionization energy. To explain ionization energy properly, I'm going to share my screen. When I'm sharing my screen, you guys are supposed to like, subscribe, and share my channel. And the other thing, you must know that the notes are available on my website. The topical past papers are available on my website, right? These notes, the one that I'm sharing right now. What is ionization energy? Amount of energy required to remove one electron from each atom of one mole gaseous atom, or amount of energy needed to remove one mole electron from one mole gaseous atom to make one mole gaseous unipositive ion. Amount of energy needed to remove one mole electron from one mole gaseous atom. One mole electron from one mole gaseous atom to make one mole gaseous unipositive ion. Or amount of energy needed to remove one electron from each atom of one mole gaseous atom. It's the same thing. There is no difference. Now I'm going to apply it, right? I'm going to apply this. Then we are going to study what is the trend down the group and what is trend across a period, right? So, look, ionization energy. Ionization energy, kilojoule per mole of the electron removed. You have one mole. You have one mole gaseous aluminium. It is not solid, it is gaseous. Like there is no other bond. These are just atoms. These are one mole atoms, nothing else. And when you are providing energy to the atoms, like suppose this is atom, you are providing energy. This energy will take out the electron from the atom. So amount of energy needed to remove one electron from each atom. As a result, each atom will turn into what? 1 plus. First ionization. Aluminium, 1 plus. Second ionization. Aluminium, 2 plus. Third ionization. I can show you this. Look. Data booklet. I know it's Pearson data booklet, but the information are much more. No, not this one. This is your aluminium. I'm going to relate it to this aluminium 30. This is the nucleus. Then first shell. Then second shell. And then third shell. Right? Aluminium is 13. Nucleus, there are 13 proton, 2 electron, 8, and then how much? 3. Right? So, aluminium, gaseous, giving first electron, removing first electron. First ionization. You know how much energy is needed? 578. Now, after removal of 1 electron, the number of electrons decrease. The protons are more, but now the protons are more than the electron. Look. Initially, proton and electron are equal, 13 proton, 13 electron. But now, the electrons are less. So the protons are more for these electrons. The electrons are getting less. The electrons are getting less. The nuclear attraction increase. The nuclear attraction increase. We are getting closer to the nucleus. So first electron need how much? 578. Now, when it is second, 1 plus, I'm going to write it pink. 1 plus gaseous. 2 plus another electron. 2 plus 3 plus another electron. 4 plus another electron. So if you look, 578 first, 1,800 second, 2,700 third. But look, first electron removed at 500, 1,800, 2,700. But now what? 11,000. Don't you think that there's a huge jump from 500 to 18, from 18 to 27? But now it's how much? 11,000. Look, 500, 1,008, 1870, 2745, and now 11,000. Why such a huge jump? Can you think? Because the first 3 electrons, they are in the outermost shell. The first 3 electrons are in the outermost shell. but the fourth electron is in the next shell, closer to the nucleus. This shows that when the quantum shell will change, there will be a big jump, big increase, because the electron gets closer to the nucleus, they experience more nuclear attraction. So look, 11,000. Now another thing, like count, like there are how many electrons? 8 in the second shell. So if I use these 3 are in the outermost shell, then 11,000, 14,000, 18,000, 23,000, 27,000, 31,000, 38,000, 42,000, and look at this, 200,000, if I'm not wrong. 1, 2, 3, yeah, like 200,000. Why such a big jump? Because again, quantum shell change. Look, the first, like, I know there is an increase, but then there is a sharp rise because quantum shell changes. And then there is increase, and then there is sharp rise because quantum shell changes. And now 20 to 22. Do you get? Look, if I plot it. Ionization energy. Aluminium. 2, 8, 2, 8, and 3. So 1 electron, 2 electron, 3 gradual rise, then 4th sharp rise, 1, 2, 3, 4, 5, 6, 7, 8. And now again sharp rise. Why? Why? These are electrons removed. Huh? So this is, are we getting closer to the nucleus? Yes. Nuclear attraction increase. This is first shell. This is second shell. This is third quantum shell. Quantum shell changes. We are getting, quantum shell is changed. We are getting closer to the nucleus. If you look at this whole data, look. After 500 to 7,000. Why? In lithium, there is 1 in the last, there are 2 in the second. So first at 500, the second one is at 7,000. From 500 to 7,000. Why? Because quantum shell changes. Beryllium, 900, 1,700, and 14,000. Why? Because in the outermost 2, and the third electron is in the next shell, and the next shell nucleus. In boron, 800, 2,000, 3,000, and 25,000. Why? Because 3 electrons are in the last, 3 electrons are in the last, and 2 electrons are in the next. So there's gradual rise, and then there's sharp rise. Look at this carbon. 1,000, 2,000, 4,000, 6,000, and 37,000. Carbon, 2 and 4. First electron at 1,000, 2,000, 4,000, 6,000. But electron from there at 37,000. So when there is sharp rise, quantum shell is changing, right? So if I take you to the notes, wait a minute, look at this. Look. So we are removing electron from the outermost first, and then we remove electron we are moving closer toward the nucleus. After each electron removal, the repulsion decrease between the electron. The rest of the electron experience more nuclear attraction. Therefore, the successive ionization energy increase. 13 proton, 13 electron, 12 electron, 11 electrons are getting less. The nuclear attraction is getting more. Electrons are getting closer to the nucleus. Successive ionization energy shows sharp rise when quantum shell is changed. When quantum shell is changed. This I've done now with you people, right? So if this is the ionization energy of an element, look at this. 7, then sharp rise, then 8, and then sharp rise, then 2. What this shows? How many electrons are in the last shell? 7. This is N1, this is N2, this is N3. There are 3 quantum shells. The period number is 3, but group number is 7. N1, first shell, second shell, third shell. In the third shell, there are 7 electrons. So period number is 3, group number is 7. Look at this. This is element X. In element X, look at this. 1, 2, 3, 4, 5, 6, 7. 7. After 7 electrons, there is sharp rise. So group number is 7. Both elements are in period 3. Both elements are in period 3. So this element, the dotted one, sharp rise after 7. So it is of group 7. Period 3, so it's chlorine. And what about this one? The solid line, the Y. Sharp rise after 5th. Because there is sharp rise between 5th and 6th ionization. It is group 5, it is group 7, group 5, group 7. Period 3. Sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, and arc. So group 7 and group 5. Group 5, sharp rise to 5, sharp rise here, group 7, and group 5, group 7 element. So X and Y, P is in group 5 and Y is in group 7, right? Now, another question. Successive ionization energy of element X are shown. Element X, successive ionization. Removal of first, removal of second, removal of third, removal of fourth, fifth, sixth. This is 800, 1800, 3000, 3600, 5800, 7000, and 13,000. So 7,000 and 13,000 is the big difference. You know, this shows that all these electrons were in the last shell. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. The 7th electron was in the next shell, closer to the nucleus. Therefore, since it is in group 6, I know in group 6, it's oxygen, sulfur, SETE. Which element? TE. Now, ionization energy down the group. What is happening down the group? Is the size of atom getting bigger? The nuclear attraction decrease? Down the group. Down the group. Proton increase. Down the group, proton increase. Number of shells, 2. Number of shells, 3. Number of shells, 4. Are the proton more? Are the shells getting more? Shielding electron is also increasing. The proton increase, the shielding increase, the attraction increase, the repulsion increase. The attraction increase, the attraction increase, the repulsion also increase. They balance each other. The nuclear attraction for valence is less. Why? Because it's getting far. जैसे प्रोटॉन बढ़ते हैं ना, शील्डिंग इलेक्ट्रॉन भी बढ़ते हैं. अट्रैक्शन भी बढ़ती है, रिपल्शन बैलेंस हो जाता है ना। ऐसा होता है जैसे कुछ हुआ ही ना, यानी न्यूक्लियर अट्रैक्शन में कोई फर्क ही नहीं आया, न्यूक्लियर अट्रैक्शन में फर्क नहीं आया, लेकिन बैलेंस उधर ही दूर हो रहा है हर दफा। हाँ, करीब फिर दूर, फिर जब प्रोटॉन बढ़े हैं लेकिन अट्रैक्शन नहीं बढ़ी, अट्रैक्शन उतनी ही है, तो फिर इसका मतलब है कि जो वैलेंस है अगर वो दूर जा रहा है तो उसके लिए तो वो अट्रैक्शन कम है, तो इसका मतलब है कि साइज बड़ा हो रहा है, कम एनर्जी चाहिए इलेक्ट्रॉन निकालने के लिए। Ionization energy decreases down the group. Why? Because nuclear charge and shielding electrons increase by equal number or amount. Therefore, they balance each other. The valence electrons are getting far. As the number of shells are more, the valence electron experience less nuclear attraction. Size of atom increase, the ionization energy decrease. Ionization energy decrease. So what we studied? What is ionization energy? Energy needed to remove one electron from each atom of one mole gaseous atom. You are taking out electron from atom against nuclear attraction. So each successive electron need more energy because the electrons are getting less. As a result, the attraction increases for this because the protons are now more than electrons. So successive ionization energy is increased, sharp rise when there is change in quantum shell, and down the group size increase, the ionization energy should lower. Next topic would be what? Ionization energy across a period. So I have to give separate time to this topic, right? This is in my next recorded lecture. उस वक्त तक के लिए इजाजत, अल्लाह हाफिज. Don't forget to like, subscribe, and share my channel. And for the notes and for the topical past papers, you can go. All these are available on my website. I hope these all help you a lot. Okay, Allah Hafiz.